We're working on quadratic equations with the quadratic formula, solving quadratic equations using the quadratic formula. To use a quadratic formula is any quadratic, meaning we have the highest exponent. The degree, which is the highest exponent, is a 2, so the highest exponent squared. We have ax squared plus bx plus c. That's our general form of a quadratic equation. Notice how the a, b, and c are the numbers in front of the variables. They are the coefficients. So my a would never be ax squared, or bx would never be an option because the x's are not included. Our quadratic formula is x equals, right? So we're solving for x, so we don't want to plug x into there. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I read it as opposite b just because it's easy to remember. If it's positive, we make it negative. If it's negative, we make it positive. It just makes it nice and simple. Going into our examples, we are going to identify a. Well, a over here, well, boom, that's negative 3. It's the number in front of the squared. I didn't take the x squared. We're going to go ahead and take b. There's 5. And we're going to go ahead and take c. c is 6. Boom. So I took only the numbers. If these were negative, I would have brought the negatives. They just have to be positive. So whatever the numbers are in front of the variables or the constant itself, I go ahead and use those and I label them. Now I'm going to go ahead and I'm going to plug into my formula. So it's opposite is x equals opposite of b. Well, b is positive, so I'm going to make this a negative 5. Plus or minus the square root of b squared, so 5 squared minus 4 times a, curve there, times c. And it's all over 2 times, well, a, which is negative 3. And what I'm going to do here is I'm just going to kind of go piece by piece. Negative 5, there's nothing I can do there, so I'm just going to rewrite negative 5. I'm stuck. Going inside the parentheses, I have 5 squared, which is 25. I have negative 4 times negative 3. Negative 4 times negative 3, that makes that a positive 12. Negative 4, negative 3, positive 12. And there's a positive 12 times 6. This is going to be plus, and what 10 times 6 is 60, 12, so 72. So it'll be 25 plus 72 all over, well, 2 times negative 3 is going to be negative 6. Cool. All right, that's the last I can do there. So equal sign again, negative 5. Can't do anything with that still. Plus or minus, well, the square root now is 25 plus 72. So it's going to be a 97. We have a negative 6. Now, because this is negative, I'm going to flip this sign. So negative 5 divided by negative 6 is going to end up being positive 5, 6. So I'm going to get rid of both of these negatives. Now, what's also happening, just so in case any math people are on here that they don't yell at me, is what we have here is we have equals negative 5 plus radical 97 divided by negative 6. So what's really happening is we have negative 5 divided by negative 6 plus radical 97 divided by negative 6. So these negatives become a positive, so we have a positive 5. This negative is actually going to turn this to be a negative. So this is a negative square root of 97 divided by 6. And then the other option was a negative 5 minus square root of 97 divided by negative 6. So we have negative 5 over negative 6 minus square root of 97. Again, this makes it positive. Now this negative is going to turn positive now because of this as well. So it ends up being, it flips both signs, the 5 sign and the square root of 97 sign, but because it's plus or minus, this minus becomes the plus, this plus becomes the minus. So I would say my final answer was 5 plus or minus square root of 97 divided by 6. So I just basically eliminated these two negatives, and this took care of all this situation. And this is it. This is done. This is simplified. It's the best we can do. Square root of 97 is not can't be reduced. So we're kind of done with this one. That's the final answer. It's ugly, but that will be acceptable. we're going to have ugly answers and everything's going to be pretty, unfortunately. All right, now let's go to the other example. Cool. So A is going to be 2, right? Number in front of the x squared. B, 7, number in front of the x. And then C is my constant, 4. All right, I'm going to plug it into my formula. X equals opposite of B, so -7 plus or minus square root of 7 squared minus 4 will A, and then C. All right. And then we have on the bottom 2 times A, which is 2 times 2. All right, just plug that right in from the formula. And then what I'm going to do is I'm going to simplify what I can. I can't do anything with a -7. It's just kind of sitting there. Right, square root, well, 7 squared is 49. And then we have -4 times 2. -4 times +2 is -8. -8 times 4, right? So this is just 4 times 2 times 4. So it's -4 times 2, so it's -8. -8 times 4 is going to be a -32. And then divide that by, well, 2 times 2 is 4. Keep going, keep simplifying. Boom, there you go. And again, that will be my final answer. That's the best I can do. Assuming I didn't make a mistake, which I might have, who knows. I'll quickly do, say I get to something like this, and I'm just going to get us to a spot. Say we had -3 plus or minus the square root of 20, and actually think ahead here. Let's make it -6 plus or minus the square root of 20 divided by 10. Whatever, I just made it up. Now, the square root of 20. I know radical 17 isn't going to be divisible and has no factors that are divisible. I knew the same about 97. How would I check that if I don't know? I have 20. I'm going to do all the factors of 20. So 1 times 20, 2 times 10, 4 times 5. All right, so these are all the factors, just like 17 was going to be 1 and 17, and that's really going to be it. And if you don't, if you struggle with factors, basically you can just take 20 divided by 1, then do 20 divided by 2, and just keep making the chart. Or there's that factor chart that is, I think it's on the Google Classroom uploaded now. If you don't have access to it or need it, let me know and I'll send it to you. So it's just, this stuff's easy. And what we're looking for is we're looking for a perfect square. So we know what our first X amount of perfect squares are. 1 is a perfect square. 2 is not, 4 is a perfect square, 5 is not, 10 and 20 are not. So we have 1 and we have 4 options. I'm going to go ahead and choose 4. I'm choosing the biggest. So I always look for the biggest perfect square. And what I'm going to do is rewrite this, -6 plus or minus the square root. Instead of writing the square root of 20, well, 4 times 5 is 20. I'm going to make this square root of 4 times square root of 5 divided by 10. All right, cool. Now I'm going to simplify again. Plus or minus. Well, the square root of 4, the reason why we chose it is because it's a perfect square. So the square root of 4 is 2. We got square root of 5. Divide that by 10. And now what I have here is, scroll up here so I give myself some room, is, again, this is a plus or minus, so we have 2 options here. So we have -6 plus or minus, and I'm sorry, we have the plus or minus, so we obviously have a plus and a minus version of the numerator, but that plus or minus also divides this into 2 separate fractions with the same denominator. -6 divided by 10, well, that's going to be -3/5. This is going to be radical 5. The 2 cancels with the 10, and it's going to be 5. So these are acceptable, or they may have it all as 1. Both of these are acceptable. This or this, and apex is probably going to ask you at different times for both of them. So you have those. So if it's not a perfect square, we have to look at the factors. If the factors have a perfect square within them, we can simplify it further. If it doesn't, we're stuck here.